Katrina. It's hard to believe it's been 10 years since Katrina, but it has. Rick, since he was going to be here, graciously agreed to give the talk in place of Max. So without further ado, Rick, it's yours.
Hey, hi again. Yeah, I talked to Max again last night and got some final thoughts he had on what to say about what's happened since Katrina. And I'll hit on most of the high points, the main topics he wanted to hit on. But he felt, and I felt reasonably comfortable talking about this in his place because I was there at the time. I was a hurricane specialist from 2005 to 2008, so my first season as a hurricane forecaster was 05, including Katrina, and I had been at the Hurricane Center for a few years before that. And during Katrina, I did a few of the forecasts. I was mostly on midnight shifts, as it turns out, including at the Hurricane Center overnight after it had come over us, and then for the subsequent nights as landfall got closer. And then when we got to the last day, I was doing the media in the middle of the night when Max was trying to get a little bit of sleep. And then after the event, even though the season remained quite busy, I and Jamie Rome, who's now the Storm Surge Unit team lead at the Hurricane Center, and Dan Brown, who's now our warning coordination meteorologist, the three of us authored the Katrina report for the Hurricane Center, which we were working on while the rest of the season was going on. So I had to do a lot of the documentation of what happened, both meteorologically and the impacts. So going back and looking at that report a decade later brings back a lot of interesting thoughts and recollections. So, but I'm not going to talk mostly about the storm itself. We don't need to go to talk about all of that with a group that probably knows a lot about what happened. But there is a lot that has changed since Katrina, either because of Katrina or partially. And it's a good benchmark in time to review some of those things. So this is the season overall that I just referred to, and certainly Katrina did not happen in isolation. The overall activity levels, this was not just an above average year, it was a very abnormal year in so many ways. In fact, I just read the part of the report that we wrote last night. It was so difficult to keep up with the record being broken during that season that as I was writing the Katrina report, I had to keep editing it because the first time when I started writing it, it had broken the pressure record, and then for lowest pressure, and then we had Rita, and then we had Wilma, and so the records were being rewritten as the weeks went by during that season. And so here's the track of Katrina, and this is for a couple of reasons, to just refresh our memories of some of the dates and where it was on what dates. I'm going to show you some of the forecasts and the verification and some of the products that we issued during various parts during the evolution of the system. But one thing to remember about Katrina that is a good message going forward is the biggest, baddest hurricanes that we have making landfall in the U.S. often form right on our doorstep. And no exception with Katrina becoming a tropical cyclone over the Bahamas. So here's the first advisory issued by the Hurricane Center, and at the time, the cone was a bit larger than it is now. I'll show you a comparison of how it might look nowadays in a little bit. But here we are about 48 hours before potential conditions of tropical storm force, and remember at the time there was no 5-day graphical tropical weather outlook. There were no probabilities in the outlook about the chances of formation. So when we issued the first advisory, there wasn't as much visibility on it as I think there would be today. And because of the size of the cone, at this point it's so early in the game that the eventual impacts in New Orleans were pretty far from our minds, even though it wasn't that far away from the Gulf. Okay. So then a little bit later, here's our forecast of explicitly a hurricane making landfall in Florida, and there's the guidance out of our ATCF system on the left. and you see the actual track in white and then the various colors. So the guidance was in pretty good agreement at this stage when you are about 5 days before final landfall of a track a lot farther to the east. So, however the official forecasts were off to the east, it largely had to do with the guidance at the time. And this is when it came ashore over South Florida. Very asymmetric convective pattern, such that there weren't many impacts in Broward County, but we had a good amount of wind and heavy rain in Dade County, and there were some fatalities in Dade County, fallen trees, for example. And the center of Katrina did go right over the hurricane center. We measured a pressure of 983 millibars, and then when the eastern eye wall, the stronger part of the system went by, we had a sustained 60 gust to 70. But it did go right over, and I distinctly remember trying to sleep in my office in those hours, in the evening hours, as it was going overhead, because I was doing the midnight shift later that night. And because I obviously had to get to the hurricane center a lot sooner than that radar shot. Okay. So it was tropical storm for a little bit. Made landfall as hurricane near the Broward Dade line, 70 knots. Briefly weakened tropical storm over the Florida Peninsula, or not a very good excuse for land that far south. It spent a bit of time over the Everglades, but didn't take long to become a hurricane again, coming offshore. But then it went through this period where it was struggling to intensify. Went through some internal structural changes, and it kind of sat at 100 knots in the southeastern Gulf of Mexico. But it was by this time that the guidance had dramatically shifted, and then we had to make that difficult call about how far and how quickly to follow the guidance shift to the west. And I think fortunately for us, we made it relatively quickly. We didn't wait too long to follow that guidance westward. But about 2.5 days prior to landfall, which from this point forward, the guidance remained pretty consistent. And that's one of the things that was beneficial for decision making and getting the word out, is that once we were inside of about 2.5 days, the guidance and the official forecast didn't shift a whole lot. In fact, I remember one midnight shift spending quite a bit of time trying to analyze the last 2 days of model trends to see if there was any leanings, and it had the shifting stopped. And I remember being on the hurricane hotline with one of the other offices that would also do a forecast and give us their insights, and we debated for a good 5 to 10 minutes over whether or not we thought the shifting had stopped and whether or not we wanted to try to start getting just a little bit ahead of it and so forth. But we stayed there, and the guidance didn't move a whole lot after that. So when you look at the historical errors, which I'll give you the numbers for in a little bit, by historical standards, at the time, the forecasts for Katrina were quite good, but they weren't the same in terms of the errors all the way through its life cycle. I'll show you the stats. Now, what if Katrina happened today? What would the cone look like? Just to give you a visual of how things have changed in forecast accuracy with the track. Upper left is the 2005 version, and then if we're using this year's new version of the cone, that's how much more narrow it would be. Now, you might be thinking, oh, that's good. Not all good, because the narrower the cone gets, the less useful it is, or always has been kind of not useful in many ways, but the less useful it is, the narrower it gets for conveying where the hazards are going to occur. And for a very large hurricane like Katrina, a really narrow cone like that, and especially when you get closer to landfall, and when you get 48 hours, 36 hours out, and the cone as it's crossing the coastline is a lot narrower than it was in 2005, I fear the present day would perhaps give some folks not in the cone a little bit of a false message. So all the more important that we're moving toward all these other products and warnings that convey the hazards, whereas the cone is really bad at doing that, and it's getting worse at doing that, even though it's an indication that the forecasts have gotten a lot better. So how have forecasts improved over the last several years, including in the last decade or so since Katrina? We've made a tremendous amount of additional progress since Katrina, with a steady decline in the forecast errors. But at the time, In 2005, again, as I mentioned, the errors for track at most lead times were smaller than the previous 5 or 10-year averages for track. But for intensity, it was a different story. Katrina, as I mentioned this morning, we haven't had these kinds of cases the last couple of years, and Katrina was one of those cases with multiple rapid intensification phases and a very strong storm. And our intensity forecast, even by 2005 standards, were worse than average, were worse than the previous 5 or 10 years. So when you've got rapid intensification and peaks in the intensity that are really high, it's hard to get the magnitude and the timing of those. And that remains a problem to this day. That hasn't changed one bit in the last 10 years, the inability to get the magnitude and timing of rapid intensification. But even since 2005 and certainly since the HFIP program started about midway in the period since 2005, we've continued to make progress on track, but not so much on intensity. Now here's a look at what the track forecast errors were for Katrina at different parts of its life cycle. Now remember, where the errors are the largest, there's where the guidance was off to the right when it was weaker, and the guidance was off to the right in the Gulf of Mexico. But as it strengthened and we got into the last couple of days, the errors went down. And look at the lowest errors were on the 26th, and that was the roughly 2.5 days before landfall. So at the time when it really mattered for the northern Gulf Coast, the forecasts got better, the guidance got more consistent. But you'll notice that the overall average for Katrina wasn't as good as the seasonal average in 2005 at 72 hours. Another, I don't have a slide about it, but another thing about Katrina that gives us part of the motivation for why presently we're working on that wind timing uncertainty graphic is if you looked at the exact forecast time of arrival of winds of tropical storm force on the northern Gulf Coast, say 2 or 3 days out for Katrina, the winds of tropical storm force got to the coast 7-8 hours sooner than the official forecast said, exactly as you would have seen it in Hurricane. So another example why we really need to depict the wind arrival timing with the uncertainty built in a little bit better. That's one case we mention a lot. Now in 2005, we had a lot smaller of a product suite at the Hurricane Center in terms of the graphics especially than we do now. The wind speed probabilities were experimental during Katrina, and but we kept them and we utilized them as a pretty good case for how to utilize them, and we used the Katrina cases for years after that in the training classes with emergency managers and with media partners. For example, here we are on the 2.5 day lead time or so, and this label's wrong. This is actually from the night of the 26th. The legend is wrong. The graphic is when it's down in the southeast Gulf, and you notice there that it was already depicting a pretty significant risk over a relatively large area of the northern Gulf Coast for hurricane force winds, and not just at the coast, but a little bit inland as well. And so this was the first indication that for really intense and relatively large hurricanes, this product could be very useful for depicting where the hazards could occur, and this was a good way to deflect a little bit of the attention away from where the actual exact track was. But it was in the development and experimental stages at the time of Katrina. Also going on during Katrina was something that hasn't changed since the last 10 years have gone by, is the utility of the amateur radio station and the various amateur radio operators that can give us data and updates through ways that are less likely to fail than a lot of communications mechanisms. And when you think of all the different ways we communicate now that we rely on that may not work so well when a hurricane comes ashore, we still, to this day, rely very heavily on amateur radio, and WX4 NHC at the Hurricane Center is still a very viable part of what we do. So these are some of the reports we were getting in real time, and you notice that the amateur radio communications was one of the main ways we were able to figure out what was going on at the Slidell office at the time. And also was one of the main ways that a lot of the data that we received in real time as the storm was impacting the area, we're getting to the hurricane forecaster and putting in our public advisory and collecting for after the event. The more things change, the more some things stay the same. I think for the foreseeable future, we're going to be using the amateur radio way of communicating. And in fact, the main reason I would never let the amateur radio station ever leave the hurricane center is because it may be the only way we can talk with the outside world if we are ever severely hit. So. Okay. Now, one thing that Katrina really got going that has affected a lot of things that have changed in the last 10 years and still affects the discussion today was the Katrina-Charley comparison. That pair of systems is what really got the discussion going on the issue of the horizontal size and how that relates to storm surge. And you know that since Katrina, we have divorced the storm surge values from the Saffir-Simpson hurricane wind scale. And this was one of the motivating factors that got things going and got things moving on what is now leading to the new storm surge products and warnings. Ike played a role in there, a lot of the other big storms we've had. But you think about since Katrina and Rita and Wilma, again, we talked today about how we haven't had major hurricanes, Cat 3 or stronger, making landfall, but we've had this spate of really large systems with Ike and with Isaac and Sandy and so many, so many impacts from these really large hurricanes. But we had the really intense small one, and this comparison really got the debate going about, well, do we need a new scale? What do we do to convey the storm surge hazard properly? And there have been plenty of journal articles written about alternate scales, but we really came down largely based on this comparison and a few other examples that we just simply needed to make the Saffir-Simpson scale a wind-only scale explicitly and start really working on, for preparedness and operational products and warnings, separate products for the storm surge. And we've used probably these two storms in this comparison more often than any other in training to explain why the size of the storm has such a big effect on how much storm surge occurs. Because if you take Katrina and Charley and you take those storms and you swap them, you're going to have a much bigger storm surge disaster in Southwest Florida, even though by the category it would be one notch down from 4 to 3. And when I've told some of you this before, but when I published the Hurricane Center's report on Katrina, and we did our post-event analysis that the final landfall the first landfall and the final landfall in the northern Gulf Coast were Category 3 and not the operationally assessed Category 4. The nasty grams that I got about how could you possibly be so disrespectful after all that Katrina caused for you to knock down the category after the fact. And there were a lot of, Charley was nowhere near the disaster Katrina was, and you guys rate that higher. So it really got that discussion going even in the public's mind. But the analysis of Katrina's final landfall was benefited by some of the most voluminous collection of aircraft data we've ever had for a hurricane, especially one near landfall. And we had not only the flight level data, but we had the dropson data with all the various ways we knew by then how to reduce it to surface values. And we had the SFMR, and when it was out over the Gulf of Mexico in the middle there was no doubt from all of those data sources that based on wind data from those various sources, it was Cat 5. And then when it got close to the northern Gulf Coast, the flight level winds were staying pretty high, which would reduce to Category 4, which is what we did operationally. But the dropson data, the SFMR data, the radar data, all clearly pointed to Category 3. In fact, our final intensity analysis for Katrina's landfall on the northern Gulf Coast is arguably a little bit high because we accounted for the possibility that we didn't capture the maximum wind. We're 10 knots higher than most of the actual wind values. So it changed, the post-event analysis on Katrina changed the game and really solidified that we've got wind data upon which to make these determinations. And even though it's the third lowest landfall pressure on record, you know, it's Cat 3, and we're pretty, to this day, quite confident about that. And it was a very, very well sampled storm. And we didn't do the size comparison for the first time after the fact with Katrina comparing to Charlie, because as Max would tell you if he was here, he spent a lot of time on the air as Katrina was approaching, urging people not to compare it to Camille, and he's known for saying, even after the fact, that Camille killed a lot of people in Katrina because people thought if they got through Camille that they could get through Katrina, which was a much, much larger system. And the storm surge you get in any one spot, depending on the exact track, the size, the forward speed, so many factors. And so the comparison game has bitten us more than once. So how have we proceeded with handling, Katrina's legacy as being, mainly a storm surge event? A lot has happened in the last 10 years, not just because of Katrina, but we can certainly point back to Katrina and look at how it was during that really significant event. Again, there was no public-facing product from the Hurricane Center showing people where storm surge could occur. That only happened last year, and experimentally. But we've had display programs that the emergency managers have had access to for a while, and they had access to, for example, these meows in the slosh display program. But you'll notice that this was not something simple to interpret. You had to kind of understand what you were looking at. This was above NGVD, and it's a composite, and again, not a public-facing product. And in our advisories, we were very, very general in what we said about what the storm surge could be. And remember the famous wording we used for years and years? Storm surge of 18 to 22 feet could occur near and to the right of where the center makes landfall. It's over normal tide levels, large and dangerous battering waves on top of that. And none of that told the public, how high the water was going to get and how far inland it was going to go. What we were communicating publicly was nowhere near what we are today. And here's another interesting thing about how the forecast played out. And if you read our tropical cyclone report, it says in there, it got one paragraph in there about how 24 hours, back then, 10 years ago, but feels like back then, we 24 hours in advance of landfall was the first time frame at which we would put anything in our public advisories about storm surge values. And so about 24 hours before it came ashore, we had values in there that were in the 20s, up to 28 feet. And that ended up generally verifying. But those storm surge values in our public advisory were contingent upon a forecast of a much stronger hurricane at landfall, not a less intense, larger hurricane at landfall. In other words, we got it generally right for the wrong reason. The intensity forecast wasn't accurate enough to get that so correct. But as it turned out, we had the right general idea. There was going to be a big storm surge event, but certainly not communicating it the way we are now. So this is an animation. Actually, Brian Zachary, our storm surge unit person from the Hurricane Center, who's going to talk to you tomorrow, he'll show this to you and get into more detail. But this animation is a nice, quick way to really get a feel for how we have changed, how we calculate and convey storm surge. So this is one way of looking at storm surge, but what if you actually convert that into inundation above ground level? And now you've got a much clearer depiction of how high above ground level the water could get. Now, of course, what else has happened in this part of the country? Now you've got the hurricane risk reduction system in place. And this gives me an opportunity to mention that we're not going to try with our new potential storm surge flooding map to paint how much water and how high above the ground is going to occur inside the risk reduction system in the New Orleans area. It's pretty hard to forecast those values for a system that they have control over opening and closing the barriers. So we're not going to try to do an engineering exercise in a forecast product. But this will require some more discussion with the forecast office there and officials there, that we may utilize the new storm surge warning and even light it up inside the risk reduction system if being isolated in that area or the potential of water getting in there is something we want to highlight. But again, the fundamental switch in the years since Katrina at the Hurricane Center, going away from storm surge over a datum to doing inundation, the flooding above ground level, is a fundamental change, which I think is absolutely the right way to go for so many reasons. Okay? So here's where we are today, now conveying experimentally and maybe in 16 an operational product to convey the potential for storm surge flooding above ground level and headed toward the warning. And again, Katrina didn't start the discussion about the need for a storm surge warning. That started even beforehand, but Katrina and many other storm surge events since then have really galvanized the effort. Okay. Another thing I wanted to highlight was how the National Hurricane Program has evolved. You may or may not realize that after Katrina, there was something called the Post-Katrina Emergency Management Reform Act. The EM community calls it PCEMRA, I guess. And one thing that act did was mandate congressionally that FEMA, via the National Hurricane Program, would provide technical assistance and resources to assist state and local governments in putting together these various tools that they use for evacuation decision making, including a mandate to do hurricane evacuation studies, HES. So that's one of the big legacies of Katrina, how it has really fundamentally and formally changed the emergency management world. And that's affected us at the Hurricane Center because we're not directly congressionally mandated, but FEMA is mandated to provide storm surge analyses, and they turn to us to do that. The National Hurricane Program, the FEMA, NOAA, Hurricane Center, and Army Corps collaboration has really blossomed in the last 10 years. And the development of these various tools, the hazard analysis is the Hurricane Center doing the storm surge modeling ahead of time that is used by state and local emergency managers to construct their evacuation zones. The evacuation studies consider all kinds of factors that affect when they need to call for evacuations. It supports the HUREVAC tool that the emergency managers use. All the training classes that we do at the Hurricane Center are funded and coordinated through this program. The Hurricane Liaison Team, the Interagency Coordinating Committee on Hurricanes, we and the federal and state emergency managers, where we decide on the priorities for these tools. It's really changed. So I think that's one of the big federal government improvements since Katrina. And the other thing that I would say that has changed dramatically at the Hurricane Center since Katrina is staffing and how we are utilizing those staff and the kind of staff that we have. This is picture's about a year and a half old, so it doesn't have everybody who's currently in our storm surge unit. But our storm, since I had to do the post-event analysis for Katrina, I interacted with the storm surge folks at the time. But what we've done to the storm surge program at the Hurricane Center since then, under Jamie Rome's leadership, is just phenomenal. The kinds of expertise that we now have at the Hurricane Center, some of it funded by FEMA, others funded by other agencies and other projects. But we've got oceanographers and storm surge modeling specialists and GIS specialists, and some of those folks have a meteorological background, and they've just taken this to a whole new level. And that's enabling us to do our part in the National Hurricane Program a lot better, come up with these new products and warnings. And oh, by the way, how many hurricane specialists were there on staff at the Hurricane Center during Katrina? It wasn't the 10 we have now. That happened post-Katrina. Now, yeah, it was 6 at the time. And there was no Hurricane Specialist Unit branch chief. So at the time that I was a hurricane specialist, there were 6 of us, and we all reported to the deputy director. Now we've got a Hurricane Specialist Unit branch chief, and we have 10 hurricane specialists. Now you might be thinking, okay, now you got all these storm surge unit people, you got more hurricane specialists, you guys must have plenty of time on your hands. Well, but it's that additional staffing and change in focus that has enabled us to do all these new products, and we're still testing stuff internally. We're testing 6- and 7-day forecasts internally. We are testing have been testing the watches and warnings and forecasts before Genesis internally. And the coordination that our folks are going to have to do with the WFOs on the storm surge warning, that's going to require more people. So we've utilized the folks to do a lot of new things, and they're pretty busy on shift. So lots has changed during Katrina. I think a lot of it for the better, but One thing that hasn't changed is, as we talked about this morning, people are not prepared. That hasn't changed one bit, and the data in that FEMA report basically explicitly says that. People are no better prepared than they were several years ago, so somehow we got to turn that ship around. So, thanks. Yep.
Just
Any
a quick
quick
announcement, Bill,
questions?
before you get started. Live shots, you notice the times if you're up there. We've pretty close to getting to that 4 o'clock hour. We're at 3:24, so keep track of the time. You'll need to get out to your live shot area at least 10 minutes ahead of time.
Okay. With that in mind, I guess we will go to the questions for now. We got one more speaker today. And we're going back into hurricane chasing. And this is a guy from Los Angeles. He's not a meteorologist, but he loves chasing these hurricanes. He's been to Tacloban last year for the big